Hello and welcome to this Estranged development blog video. In this video I'm going to show you the death animation for the human characters in Estranged. So here are some zombies. So I'm going to shoot this guy in the back of the head. And you see he fell forwards before he ragdolled. So I'm going to shoot this guy in the front of the head. You can see that he fell backwards and then ragdolled. This guy I'm going to shoot from the side. See, he fell that side, the opposite side to my shot. And, let's not let him attack me. He's attacking anyway. Oops, I'm going to shoot him from this side. And you can see he fell that way. So very, very simple system. So what's happening here is it's transitioning between animation and physically simulated mesh and ragdolling. So let's do it again. This guy's going to fall forwards. This guy's going to fall backwards. This guy's going to fall backwards. So it adds a little bit more realism to the world. It allows it to be a little bit more dynamic. You see, these guys actually used the same death animation because they're stuck in the same pose. It is randomized, but I think unfortunately I've been given maybe not the same animations, but they're a little bit similar. So there's more animations for falling backwards than there are falling left and right and falling forwards, because that's typically what you're going to do. You're going to shoot the infected head on because it's heading towards you. So how does this work? Well, I'm going to go into the code first, which is all available on GitHub. All of the AI characters in Estranged inherit from this EST AI character class. So if I go down to the on-death implementation, which is here, you can see we'll ignore this bit here because that's just ejecting the controller. And there's some collision changes. So the important variable here is defer death ragdoll. And if this is set, this will spin off a timer to then ragdoll the mesh at a later time. Now, if it's not set, we just become a ragdoll immediately. So we set this timer, we set it to defer death ragdoll time, and once the timer kind of fires, we call this become ragdoll method. So either do it immediately or do it in X seconds. And become ragdoll is at the bottom of this file. It just sets the animation to null, sets the animation instance or the animation blueprint to null, and tells the mesh to simulate physics. So going back to the code here, I'm going to go into the animation blueprint. So this is the zombies animation blueprint in Estranged. And what it's doing is it's bound this when it initializes, it gets the character and it binds an event to the on-death event from the health component. So this is just a component that tracks health, really. It just tracks resource, in this case health. And then once that on-death event fires, it then pulls the last damage direction. I'm jumping ahead myself a bit here. So it pulls the last damage direction vector from the health component. This is something the health component keeps track of. It's kind of within its remit. It records that information. And then we get the local rotation from the world direction here. So what I'm going to do is I'm going to show the implementation of that. It's also in EST core. So if you go EST core private, EST gameplay statics, and with any luck, it should be the last method here. Local rotation from world direction. There we go. So what that takes in is a world direction vector, which is what we're getting from the health component. This is just something the health component caches away from the damage event it gets. And then we've got the actor transform of this character. So it pipes that into there. And all this method does is it calls the Kismet math library and says inverse transform rotation. So we want to take the world transform, we want to take the world direction, and we make it into a rotation, and we get out of that a local rotation. So that we get a rotation local to the character from that world direction. So what we do with that is we just take the yaw and then we say angle to relative direction. So I've got a method here, it's just defined in blueprints. All it does is it says if just kind of round the angle to the nearest increment, and then if it's 0, if it's around 0, then it's forwards, or it's 360, it's forwards. If it's 90, it's right. If it's 180, it's backwards, and else it's left. So very simple. There's just a little enum that stores this relative direction, and that's what the animation blueprint will store away as a variable. So it sets that, and then it tells the animation blueprint that the character is in fact dead. So if we go to the animation graph here, this is the second part of it. All it's doing here is it's blending between the normal pose. This is kind of the normal pose driver for this character. If is dead is false, it drives it through that. If is dead is true, we go up here. And then what we do here is we just take that enum, that last damage direction enum, and we pick an animation based on that. So we've got this random sequence player for the falling backwards animation. So you've got death 1, death 2, death 3, and then for the other ones we've just got that single animation. So when we get shot from behind, we fall forwards. When we get shot from the left, we fall right. When we get shot from the right, we fall left, etc. So that's very, very simple. That's the animation blueprint that drives all of this. So what I'm going to do is I'm going to go back to the game here. I'm going to give you another shot of it. So we'll let's slow it down a little bit. So if we go slow-mo, 0.25, go 0.25. You can see they've slowed right down. So I'm going to shoot this guy from behind. You see he falls, and then he starts simulating physics. So let's shoot this guy from in front. You see, shoot him, oh, he falls, he animates, and then he transitions to simulate physics. So when you're looking at it in slow motion, you can really see what's going on there. But obviously, if you're playing it at real time, it kind of blends naturally. You can't really see it. So that is the death pose feature in Estranged Act 2. Thank you very much for watching.